Welcome to myprojectbazaar.com. Let's discuss about the product. Our product is rate adaptation for 802.11 multi-user MIMO networks. In multi-user MIMO, that is multiple input, multiple output networks, the optimal bitrate of a user is highly dynamic and changes from one packet to next. This breaks the traditional bitrate adaptation algorithms, which rely on recent history to predict the best bitrate for the next packet. To address this problem, we introduced turbo rate adaptation scheme for MU-MIMO, that is multi-user, multi-input, multi-output LANs. Turbo rate shows that clients in MU-MIMO LAN can adopt their bitrate on a per packet basis if each client learns two variables. Its SNR when it transmits alone to the access points and the direction along which signal is received at the access point. Turbo rate also shows that each client can compute these two variables passively without exchanging control frames with the access point. A turbo rate client then converts its implementation in USRP N200 shows that traditional rate adaptation does not deliver the gains of MIMO wireless LANs and can interact negatively with multi-user MIMO, leading to low throughput. In contrast, enabling multi-user MIMO with turbo rate provides a mean throughput gain of 1.7x and 2.3x for 2 antenna on 3 antenna access points respectively. Wireless LANs are facing two trends. First, the number of antennas on an access point is increasing steadily, with typical access points today having 2 or 3 antennas. Second, there is a proliferation of small Wi-Fi devices. For example, sensors, smartphones and game consoles, which have a small form factor and strict power limitations, and hence typically use a single antenna. These trends cause a multi-antenna access point to spend a significant fraction of its time communication with a single antenna client. As a result, wireless LANs will not deliver the maximum number of concurrent transmissions enabled by their infrastructure. To address this problem, researchers have been advocated to use of multi-user MIMO, that is MU-MIMO LANs, where multiple single antenna clients communicate concurrently with the multi-antenna access points. They demonstrated that decoding that such concurrent transmission is feasible both on uplink and downlink. They also develop a MAC protocol that allows client to consent for concurrent transmission to multi-antenna access points. So far, however, research on multi-user MIMO wireless LANs has not addressed the bitrate selection problem and simply assumed that the transmission is known as the bitrate. This assumption is valid on the downlink. To see the problem, consider the scenario conducted in our product, where two single antenna clients transmitted concurrently to antenna's access point. Let's see the system flow of our product. This design shows about our product design. So our product design is initially based on MATLAB programming language. So input we are providing as a signal. So for the transmission process we are using a local server, and then that means our transmission and receiver conducted in the same path of our process. So initially the given signal is pre-processed. In pre-processed, filtering is performed to remove the noises, and then modulation is performed. Here for the modulation we are using QAM modulation scheme, that is quantitative aptitude modulation. And then the transmission is conducted for the modulation signal. Before the modulation there are a lot of process in between transmitting and receiving. So the process conducting between transmitter and receiver is such as encoding, decoding, pre-lag modification, modulating, demodulating, and FFT and IFFT process, and also interleaving, de-interleaving process also conducting uptime at the receiver part. That means the input matches with the output. Let's see the demonstration of our product. As we already discussed, our product is based on MATLAB programming. Hence, we are using MATLAB version tool. Here we have used MATLAB 2013A for the implementation. Here this is the main window of MATLAB. Here this is the directory file. Here what are the process includes in our project backup will be visible here. You can see all the backup in our process. So according to the selected process you can see the details here. This is the workspace which shows the temporary results in the mat file, and you can see and execute the values from the workspace. This is the main command window. See here the main file. This is our first executable file. So we have to run this file. We can select in every backup. You can see there are similar names with .figure file and .m file. .figure file represents the guide design. So while you are running main.m5, so it will recall that main5.figure. Yeah, so this is the guide design. Here initially I am going to give an input, voice input. So I have selected the input. The selected input is processing. So after completion the next button will open. So here I am reading that input. This is the given input, and then I am converting that into signal. So the converter signal with spectrum and frequency is here. So next process, here I have identified the given input SNR ratio, and then I am going to next process. Here the input data. So the signal is converted as a data to here. That means binary to decimal, decimal to binary, and binary to decimal. So decimal to binary is conducted in transmission before transmission, and binary to decimal is conducted in receiver part. So next I am transmitting with MIMO QAM with OFDM. The input values given is 44,100. So this is MIMO transmission amplitude signal. Hence while pressing next I can come here. So next the number of channel matrix should be greater than 3. That means at least 4. I have given that a 4 and doing channel decomposition. And for the 4 paths that decomposed channels are here, that is real time and imaginary parts, and over fading. So we can see the fading with QAM, and then QAM over correlated channels. So for 4x4 channels we have plotted there. So on next process, so here we have to select number of transmitters. I am selecting as 4 and number of receivers as 4, and the CSI table I am plotting CSI table. While plotting CSI table we can identify the parameters such as path gains and channel filter delay. So we can see what are the path gains. So this is the transmission part. So during the transmission, path gain and receiver. So during transmission there is no delay, at the receiver part delay is 4. So and then CDF function. So CDF function is plotted between transmission and receiver. So number of transmission and number of receiver, and received signal is obtained here. This is same like as an input signal because we transmitted and received the original signal here. So this is the performance. Here you can see the SNR of quality of service constraint versus SNR, and then energy efficiency graph is plotted here. Energy efficiency graph. Thank you.